In this lesson, I'll show you how to find the equation of a line in 3D space. The first of two questions reads, find a vector equation and parametric equations for the line that passes through the point 5, 1, and 3 and is parallel to the vector that has the x component of 1, a y component of 4, and a z component of -2. As you can see underneath, the point has been plotted already and it's located right here. In addition, I've taken a line from the origin and extended it to that point, and that line is a vector, and the vector has the x, y, and z components of 5, 1, and 3. So we can call r sub 0 5, 1, and 3. We don't know the direction in which this line is occurring, although we've been told that it is parallel to the vector 1, 4, and -2. This vector technically tells us the direction of this line, but it doesn't tell us exactly how long the vector that represents the line is. To represent the vector of this line, we can write down L is equal to a point on the line, which is represented by r sub 0, this vector. So I'll write down 5, I plus 1, j plus 3z, plus the direction, which is dictated by vector v, times a scalar quantity which we can represent by any letter t. So we're going to multiply t times v and add it to here. Now the reason why I'm multiplying it by a scalar quantity t is because this vector can only give us the direction of our line vector since they tell us it's parallel. It doesn't give us information about another point. Think about it. If we use the tail to tip method and add these vectors together, it might be shorter or longer than the resultant vector L. So to make it proportional to it, we need to multiply it by a factor in case it's shorter than v or longer than v. So I'm going to replace v with the components of that vector. So what you see on your screen represents the vector equation, and to get the parametric equations, I'll multiply this factor into the components found here, where I have ti plus 4jt minus 2kt, and I'll group the x, y, and z components together. Let me show you. So I have L is equal to 5 plus t in brackets I plus 1 plus 4t, and beside it we'll write down j, plus 3 minus 2tk. So whether you represent it like this or like this, either or will work as your vector equation. The parametric equations, if you look underneath here, can be represented as x, y, and z. So this part right here is x. X is equal to 5 plus t. This part is y is equal to 1 plus 4t. And that is z. That's equal to 3 minus 2t. These equations are called parametric equations of the line L through the point given to us at the beginning and parallel to the vector also provided to us. And that leads us to question number 2, where we're asked, find the parametric equations and symmetric equations of the line that passes through the points A and B. Notice the difference between this question and the previous one. In the previous one, we're given a single point and we're told the direction in which that line is going, and that's dictated by the vector. This time they give us 2 points in 3D space, A and B. So naturally we would connect a line through these 2 points, and you should end up with something that looks like this. Notice point B is plotted right here and A is plotted right here. They are connected by the line L. So to find the parametric equations, we first need to represent this line like we did in the previous example, where we had L is equal to a point, and we can choose any point that we like. Let's choose the point A, 2, 4, and -3, and add that to t times v, where to find v, we subtract the coordinates of b minus a or a minus b. It really doesn't matter. If we subtract a from b, we should end up with a vector that has the x, y, and z components of 3 minus 2, that's 1, minus 1, minus 4, that's -5, and 1 minus minus 3, that's +4. Let's go ahead and substitute that here. We should end up with L is equal to 2 plus t times 1, 4 plus negative 5 times t, and minus 3 plus 4t. This is your x, y, and z if you're finding the parametric equations. And if we solve for t in each of these, you actually get the symmetric equations, which are shown underneath. That's A, that's B, and that's C. Solving for t here, you should end up with this part, which is 1 in the denominator position, x minus 2. That's positive, so that becomes minus. Negative 5 at the bottom. It's negative because that's negative. And since this is equal to y, we write down y minus 4. Over here we have z plus 3 over 4. In question B, we're asked, at what point does this line intersect the xy plane? The line intersects this plane when z is equal to 0. So if we substitute z is equal to 0, we should end up with two coordinates, an x and a y coordinate. Let's go ahead and do that. Substituting 0 into here, we end up with 3 over 4, and we'll solve for x and y individually. So this is equal to x minus 2 on the left side, bring that 2 over. X is equal to 3 over 4 plus 2. And for y, we'll write down 3 over 4, y minus 4 over negative 5. Cross multiply, we have 4y minus 4 is equal to negative 15. Solving for y, this should give you an x value of 11 over 4 and a y value of 1/4. And there you have it. That's how to find the equation of a line in 3D space.